Welcome to GateXAIML. Today we'll solve some problems on checking the differentiability at a point. So just to recap, we say a function is differentiable at a given point if it is continuous at that point, and then the left hand derivative and right hand derivative at that point are equal. So let's begin. So given f of x equal to x cube minus 3x plus 1. So first check continuity. What's the first condition? F of 1. So we are saying at x equal to a, that is 1. So f of 1 should exist. That is 1 minus 3 plus 1. So this is minus 1. So it exists. Second, left hand limit should be equal to right hand limit. So what is left hand limit here? Limit x approaches 1 from the left hand side. X cube minus 3x plus 1. So this will be equal to again minus 1. Similarly, right hand limit is equal to limit x approaches from right hand side, cube minus 3x plus 1. So this is again minus 1. And then f of 1 is equal to LHL equal to RHL. This is L equal to minus 1. Therefore, f of 1 is equal to L is equal to minus 1. Hence, it is continuous at x equal to 1. Now, check the differentiability. How to check the differentiability? The first condition is the function should exist, so it already exists. Then you have to check left hand derivative is equal to right hand derivative. So f dash of 1 from left hand side, this will be equal to 3x square minus 3. You can also use that limit definition and then solve it. So anyway, both will give you the same result. So this is 0. Now derivative from the right hand side, right hand derivative. This will be again 3x square minus 3. This will also be 0. So both are equal. Hence, it is differentiable at x equal to 1. Okay. Next, examine the differentiability of f of x equal to mod of x minus 2 at x equal to 2. Now, first check the continuity. So, f of 2 is equal to 2 minus 2 is 0. Now, left hand limit x approaches 2 from left hand side, mod x minus 2. So when it approaches from left hand side, what will be this value? So 0. Right hand limit x approaches from right side, x minus 2. So this will be again 0. So both are equal and equal to f of 2. Hence, it is continuous. Now, check the differentiability. F dash left hand derivative of it 2. When I differentiate this, see, observe here. So x minus 2 means what? If I differentiate, so see, x is approaching from left hand side. That means I have to take it as minus x. So differentiation of this will give me minus 1. Okay. Similarly, f dash 2 from right hand side will give me plus 1. Therefore, this not equal. Left hand derivative is not equal to right hand derivative at x equal to 2. Hence, not differentiable. Why? Because even though it is continuous, it is not differential because the left hand derivative and right hand derivative are different. Next, check differentiability of the piecewise function at x equal to 0. So they are given. Let's check the continuity at x equal to 0. So let us check f of 0. F of 0 means in this function, that is x square. So it is 0. Next, left hand limit. Limit x approaches from left side. So left hand means this one, less than or equal to 0. So I have to consider x square. So this will be again equal to 0. Then right hand limit. X approaches from right hand side. So now I have to consider x, because x greater than 0 is right hand. So this will be equal to 0. So they are continuous. They are continuous. Now check the differentiability. Left hand derivative at 0. So what will be the derivative? This is less than or equal to means I have to consider this. So differentiation of 2x will get x square is 2x. So this will be 0. Next, f dash from right hand side of 0. Right hand side means this. So differentiation of x is 1. So therefore, right hand derivative is not equal to left hand derivative. Hence not differentiable. Okay. Next, find all the points where f of x equal to cube root of x is not differentiable. You have to find all those points of x where this function is not differentiable. So you can find the domains and then you can find it out. But what we can do is, just in that case, you just differentiate this curve. The f of x equal to cube root of x. I can just write it as x to the power 2 by 3. Okay. Now, sorry, x to the power 1 by 3. Now, f dash of x equal to 1 by 3 into x to the power minus 2 by 3. Or I can write it as 1 by 3 into 1 by x to the power 2 by 3. Now, if I say put 0, f dash of 0 is equal to, it becomes 1 by 3 into 1 by 0. Okay, so this is not differentiable because I'll get it as infinity, not differentiable. Because I will get a vertical tangent, vertical asymptote. So, but if you take for any other values of x, so this will definitely work. If I take minus 1, minus 2, minus 3, okay, or plus 1, plus 2, plus 3, anything it will work. So that means what? X is not differentiable when x equal to 0, not differentiable. So that means it is differentiable in the interval, differentiable in, so minus infinity to 0, so 0 not included because it's an open interval. Union, again 0 not included, then to positive infinity. So this is differentiable in these intervals and not differentiable at x equal to 0. Determine whether f of x equal to sin x plus cos x is differentiable at x equal to pi by 4. Now what they are saying, f of x is given as sin x plus cos x. So you can find the continuity first. Already we know that in the domain pi by 4, sin x plus cos x are continuous. Okay. So because pi by 4 is in the domain of sin x and cos x functions. So definitely they are continuous. You can check it, you will also get it, because sin pi by 4 is square root of 1 by 2 plus square root of 1 by 2 f of x value, f of pi by 4 value. Then they will be definitely continuous. You can check it. So they are continuous. Now differentiability. F dash from left hand side, left hand derivative of x. So if I differentiate it is cos x minus sin x. So f of pi by 4. So cos of pi by 4 minus sin of pi by 4. So this will be 0. F dash right hand derivative. So this is again cos x minus sin x. So this will come out to be again same 0. Okay, both are same. So they are equal and then hence differentiable. They are continuous and left hand derivative is equal to right hand derivative, hence differentiable at x equal to pi by 4. Next, check differentiability of f of x equal to x into mod x at x equal to 0. So let us check the continuity. So f of x equal to x mod x is f of 0. F of 0 is 0. Second, left hand limit x approaches 0 from left hand side x mod x. So x into this will be minus x minus x square. So this is equal to 0, because 0, if I put 0 it will be 0. Limit from the right hand side x into mod x into this mod x will be x, because it is positive right hand side. So this will be x square, therefore it is equal to 0. So limit to continuity, there is a continuity in the curve, their curve is continuous. Now check the differentiability. F dash left hand derivative at 0. So left hand derivative is minus x square. To differentiate, I'll get minus 2x. Okay, minus 2x. So put 0, it will become 0. Right hand derivative at 0 is equal to again to plus 2x. If I put 0, again it will be 0. So both left hand and right hand derivative are equal and hence differentiable at x equal to 0. Similarly, you can check at x equal to 1 if they are differentiable or not. Next, determine whether f of x equal to e power x sin x is differentiable at x equal to 0. So here we already know this sin x, in its domain it has x equal to 0. It is defined at x equal to 0. It is continuous at x equal to 0. Also we know that e power x is also continuous curve. E power x cannot be discontinuous. So by just looking at, you can say that this function is continuous. You need not check also. You can check for differentiability. So yeah, left hand derivative at 0. So e power x cos x plus e power x sin x. So put 0, we will get 0 only. Sorry, you will get 1. E power 0 is 1 into cos 0 is 1 plus 0. This will be equal to 1. Now, similarly, right hand derivative. You will again get same value, cos x plus e power x sin x. So this is equal to 1. So both derivatives are equal, hence differentiable at x equal to 0. Next, check differentiability of this piecewise function at x equal to 1. So let's first check the continuity. So f of 1 equal to, so f of 1 means x is less than or equal to 1. So this function I have to consider. So this will be 1 plus 2 equal to 3. So function exists, value exists. Then check for left hand derivative, so left hand limit. So x approaches 1 from left hand side. So which function I have to compare? This one again, because x is less than 1. So x square plus 2x. So substitute the value, will get 1 plus 2 is 3. Now check right hand limit. 1 plus, I have to consider this function 3x minus 1. So if I put here, it will become 3 minus 1, 2. See. So LHL is not equal to RHL, right hand limit, hence not continuous. Therefore, if it is not continuous, then it will not be differentiable. Therefore, it is not differentiable at x equal to 1. Okay. Next, determine the differentiability of f of x equal to tan x at x equal to pi by 2. So let us check the continuity. The tan is a trigonometric function, but is it defined for the domain value pi by 2? Is it defined or not? We have to check. So f of pi by 2, if the function exists, that is equal to tan pi by 2. This is equal to infinity. So it's a vertical asymptote you get. Hence, we cannot check the continuity, and hence it is not differentiable. Cannot check the continuity, and hence it is not differentiable. Cannot differentiate this vertical line also. Find the derivative of f of x equal to x square sin x and check its differentiability at x equal to 1. So x square is already seen, it's a continuous curve, and sin x is also continuous at x equal to 0. Therefore, the curve is continuous. So by observing only, you can check in the exams whether it's continuous or not continuous. Next, check the differentiability. So left hand derivative at 0. So x square sin x differentiation, you do 2x sin x plus x square cos x. So if I put 0, it will be 0. The right hand derivative, then 2x sin x plus x square cos x will be again 0. So hence is continuous, and left hand and right hand derivatives are equal, hence it is differentiable. Okay. So thank you for watching. Please like, subscribe and share. We'll start with maxima and minima concept in the next video.